Hello everyone, I'm Jivika Kanchanna and I'll be explaining you guys the solving of 8th question in homework 7. A Poisson process is defined by the following properties. That is, the number of n of t1, t2 of points ti in the interval t1, t2 of length t is equal to t2 minus t1 is a Poisson random variable with parameter lambda t. That is, the probability function, that is n of t1, t2 is equal to k, which is equal to e power minus lambda t into lambda t power k by k factorial. And second point is, if the intervals t1 and t2 and t3 and t4 are non-overlapping, then the random variables n of t1, t2 and n of t3, t4 are independent. And the third point is, at a time moment t, there is no more one Poisson point. Using the points ti, we form the stochastic processes, that is x of t is equal to n of 0, t. Therefore, this is a sample of a Poisson process for over the intervals ti, and on the x-axis we have t, and on the y-axis we have x of t. We are supposed to find that the expected value of x of t and also r of t1 and t2. Let's look at the solving of this question. When asked to find out the expected value of x of t, we know that the probability of x is equal to k is equal to e power minus lambda into lambda power k by k factorial. You know that for a probability density function, that the value for the limit 0 to infinity will be equal to 1. Therefore, e power minus lambda by lambda power k by k factorial is equal to 1. If we solve this, we will get that summation from k is equal to 0 to infinity lambda power k by k factorial is equal to e power lambda. Now, if we differentiate on both sides with respect to d lambda, we will get the value equal to summation k is equal to 0 to infinity k into lambda power k minus 1 by k factorial, which is equal to e power lambda. Now, if we solve it further, we will be getting the value that summation k is equal to 0 to infinity k into lambda power k by k factorial is equal to e power lambda into lambda, where that is summation k into e power minus lambda into lambda power k by k factorial is equal to lambda. That is, we're just sending this e power lambda this side. Therefore, we will get this equation. Now, this is what we can write it as expected value of x. Therefore, the expected value of x is equal to lambda. Now, coming to the value of sigma square, which is e of x minus neta whole square, which is equal to expected value of x square minus neta square. We know that neta square is equal to lambda. Therefore, and the expected value of x square will be summation k is equal to 0 to infinity k into lambda power k by k factorial, which is equal to lambda into e power lambda. From here, we know. Now, again, differentiating on both sides, we will get the value to be equal to e power lambda plus lambda into e power lambda. That is, summation k is equal to 0 to infinity k square into lambda power k minus 1 by k factorial will be equal to 1 plus lambda into e power lambda. Now, if we send this e power lambda this side, which is summation k is equal to 0 to infinity k square into e power minus lambda by lambda power k into k factorial, this will be equal to lambda into 1 plus lambda. Therefore, the sigma square is equal to e of x square minus lambda square, that is 1 plus lambda into lambda minus lambda square, which is equal to lambda. Now, therefore, the expected value of x of t is equal to lambda t. Expected value of x square t is equal to 1 plus lambda t into lambda t, and sigma x square t is equal to lambda t. In the second part of the 8th question, we were asked to calculate the value of r of t1 and t2. Now let's look at solving of that. That is, r of t1, t2. For t2 greater than or equal to t1, we know that x of t1 is equal to x of t1 minus x of 0. Also it is given that x of t2 minus x of t1 are independent. That is, we can write r of t1 comma t2 is equal to expected value of xt1 into xt2. That is equal to expected value of xt1 xt2 minus xt1 plus xt2. Now that can be written as expected value of xt1 into expected value of x into t2 minus x into t1 plus expected value of x square t1. Now from here we know all the values that are needed here, so we're just going to substitute them. We will get lambda t1 into lambda t2 minus lambda t1 plus 1 plus lambda t1 into lambda t1. Now if we take lambda in common, we will be getting that t1 plus lambda into t1 t2. Similarly, for the condition where t1 is greater than or equal to t2, the value of r of t1 comma t2 will be lambda into t2 plus lambda into t1 t2. Therefore r of t1 comma t2 is equal to lambda into min of t1 comma t2 plus lambda into t1 t2. Therefore this is the solving of 8th question of homework 7.